In this lecture, the goal is to chase the player if they're within the chase range. Moving enemies will be different than moving players. Unlike players, enemies should move toward the player. They're not being moved by a controller. Similar to the player, we're using the agent component. Interestingly, the agent component has additional methods for moving the player. If you check out the documentation, you'll come across some of them. Let's explore the other options for moving agents. In your editor, open the movement script. This script will be responsible for moving agents. It's not exclusive to players. At the bottom of the script, define a public method called moveAgentByDestination. Agents can be moved with AI. There's a method for setting the destination of the agent. Inside this method, run a method called agent.setDestination. The setDestination method is available to all agents. If we pass in a vector, the agent will begin moving toward the vector. In this case, the destination should be the player. However, we're not going to grab the player from the movement component. In the future, agents will have the ability to patrol and return to their guarding positions. This method should be as flexible as possible. For that reason, we're creating a method to call another method. It seems redundant, but it'll make things easier in the future. Let's update the parameters to accept the new destination called destination. Its type will be vector3. Lastly, pass this parameter onto the setDestination method. The next step is to call this method from the enemy controller. Technically, we could have grabbed the agent component from the enemy controller. However, we should leave movement to the movement component. It's considered good practice to split your logic into separate classes to keep a project maintainable. From the enemy controller, we're going to invoke the moveAgentByDestination method. First, we need a reference to the movement component. At the top of the class, define a variable called movementCMP. The type will be the movement class. Throughout this course, variables storing components will follow a specific naming convention. I'm going to use the name of the component followed by CMP, which is short for component. Oftentimes, developers will use the name of the component. However, it can be confusing to differentiate between a variable and a class. To make things clearer, I will affix the name with CMP. Of course, this step is entirely optional. You can use whatever naming convention suits your project. Moving on, let's grab the component. Try this as an exercise. Update the movementCMP variable to store the movement component. As a hint, you should perform this action from the awake method. Pause the video and give it a try. Welcome back. If you were able to grab the component, that's great. If not, let's do it together. As mentioned, classes for game objects are considered to be components. Therefore, we can use the getComponent method to select it. In the awake method, set the movement component variable to the getComponent method. In the angle brackets, add the movement class. Now that we have a reference to the component, we'll be able to move the enemy. Scroll to the update method. Run a method called chasePlayer. We're going to chase the player continuously. As mentioned before, we should check the player's distance before beginning the chase. The order of methods does matter. We shouldn't start chasing until the distance has been calculated. Be sure to call this method after the calculateDistance method. This method does not exist in our class. Let's define it below the update method. Next, let's perform a conditional statement. Write the following condition: distance from player greater than chase range. The condition we've written will check if the player is farther than the enemy's chase range. If that's the case, the enemy should not chase the player. we're going to return the method to prevent it from running further. Otherwise, the chase can commence. Run the moveAgentByDestination method from the movement component. This method needs a destination. Luckily, we have the player game object. Let's pass in the following: player.transform.position. Essentially, we're telling the agent to move toward the player. Wherever the player is, the enemy will move to the same position. Let's give our program a test. Switch over to Unity. Let's play the game. As we approach the enemy should start chasing us. During this process, the enemy may start pushing us aside. That's perfectly normal. Don't worry about it. As long as the enemy moves toward us, that's great. If we move outside the chase range, the enemy is going to eventually stop chasing us. Fantastic! We can move in and out of the chase range to force the enemy to chase us. It took a while, but achieving this behavior was well worth the effort. In the next lecture, let's improve our implementation using a design pattern.